All right, let's dive into one of the biggest, most profound mysteries in all of science. We're going on a hunt for the invisible scaffolding that, believe it or not, holds our entire universe together. Because that's the bizarre reality we find ourselves in. I mean, think about that. Everything we can see, every star, every galaxy, you, me, this planet, all of it is just a tiny fraction of what's actually out there. So what on earth is going on? Well, let's follow the evidence. It sounds so simple, right? But this one little observation completely breaks everything we think we know about gravity. When astronomers started looking really closely at galaxies like our own Milky Way, they noticed something was, well, deeply wrong. Okay, picture a merry-go-round. The horses on the very edge have to move way faster to keep up with the ones near the center, right? Well, galaxies should work kind of like that, but they don't. The stars on the outer rim are moving at ridiculously high speeds. Based on all the visible matter we can see, there is just no way there's enough gravity to hold on to them. They should be getting flung off into deep space. So, this became the first major clue in our cosmic detective story. The speed of the stars simply does not match the amount of stuff we can actually see. There has to be something else there, something invisible that's providing all this extra gravitational pull. So scientists, of course, graphed this. They plotted the speed of stars against their distance from the center of the galaxy. Now, they expected that curve to drop off as you got farther out. According to Newton and Einstein, it had to, but it didn't. It stayed flat. That flat line was like a mathematical scream, telling us that something massive, something totally invisible, was out there, holding the whole galaxy together. This was the smoking gun. But the evidence doesn't stop there, not even close. Our next clue comes from Einstein himself and his theory of general relativity. He taught us that huge, massive objects literally bend the fabric of space-time, and light has to follow those curves. So when we look at these enormous clusters of galaxies, they act like giant cosmic magnifying glasses. The light from even more distant galaxies way behind them gets bent and distorted as it passes by. The thing is, the amount of bending we see is just immense. It's way, way more than all the visible galaxies in that cluster could possibly produce. Again, something unseen is tipping the gravitational scales. And when we put all the evidence together, from spinning galaxies to bent starlight, we get this. And it's a truly humbling picture of our universe. Just look at that tiny little 5% slice labeled normal matter. That's us. That's everything we have ever seen or known. The rest, a complete mystery. So this missing mass, this invisible stuff that's holding our galaxies together, well, it has a name. We call it dark matter. It's our prime suspect for what's making up that huge 27% chunk of the universe. This slide really highlights the difference. Normal matter, what scientists call baryonic matter, is everything on the periodic table. It interacts with light, it reflects it, it absorbs it, it emits it. It's why we can see things. Dark matter, on the other hand, it seems to just ignore light completely. It doesn't interact with anything except gravity. It's a cosmic ghost. Okay, so the gravitational evidence is rock solid. We see its effects everywhere we look. But seeing an effect isn't the same as finding the cause. So for decades now, scientists have been on one of the biggest searches in history, the hunt for an actual dark matter particle. And the strategy is basically a three-pronged attack. First, we look deep. We build these incredibly sensitive detectors a mile underground to shield them from everything else, just hoping a stray dark matter particle will bump into one of our atoms. Second, we smash hard. We use things like the Large Hadron Collider to slam particles together at unbelievable speeds, trying to create dark matter in the explosion. And third, we gaze wide, pointing our best telescopes at the sky, looking for faint energy signals that might be two dark matter particles annihilating each other. And after all of that effort, all those brilliant experiments, decades of searching, the number of dark matter particles we have definitively directly detected is a big round 0. And this is the great paradox of modern cosmology, isn't it? We have these detailed maps of where dark matter is. We can see how it clumps together, forming these vast, invisible webs that stretch across the entire cosmos. We see its shadow everywhere, but we have absolutely no idea what is casting it. And yet, and this is the real kicker, it's absolutely essential. Our best computer simulations show that without dark matter's extra gravity in the early universe, nothing would have ever clumped together to form the first stars and galaxies. It is the silent architect of everything we see. You know, the discovery of dark matter proved that the vast majority of our universe is completely hidden from us. It forces us to ask this really profound question. If we were so wrong about 85% of the cosmos, what else are we fundamentally wrong about? What other secrets are just waiting for us out there, hiding in the dark?